welcome to this short tutorial on MPLS traffic engineering. This tutorial looks at utilizing traffic engineering on a VRF basis. So the idea is that we have two customers here, customer A and customer B, both with two CEs at different end of the provider's network. Traffic is going to prefer P1 as the shortest path at the moment. We're going to influence a shift of traffic to go from P1 to shift and go through P2 through P3 and finally end up at PE2. So all the configuration here is done regards to MPLS, MPBGP, the customer edge interfaces going towards the PEs are configured, BGP on the customer edges are configured as we're using BGP for the CE to PE routing protocol. So our tasks are going to be to create the VRFs on the PE devices, add those to the interfaces, add the point-to-point IP going towards the CE device on the interface, check for reachability between the PE and the CE under the VRF, then create the neighborship for the VRF, for the BGP neighborship between the PE and the CE. This should then activate the VRF, and we should then be able to see the routes imported onto PE2, and then we can go ahead and enable traffic engineering for this VRF. So start by creating the two VRFs for customer A and customer B. Okay, so we have reachability now between the CEs and the PEs, but we're not yet using BGP to do the advertisements, so we will quickly set that up. I believe that one is 2000. We'll soon find out. There we go. Okay, so show run section. Let's grab this config here. Again, configure the interfaces on PE2 going towards the CE devices. And configure VGP between the PEs and the CEs, again dropping under the address family. Here, the VRF of customer A, a neighbor statement. Thousand B of 2005 and oh, there we go. So we'll just quickly jump onto CE1, CE1 for customer A here. Show IP int bree. Right, we have a loopback here. 100, 100, 101. Show run section BGP. We've got a network statement here, which is advertising this prefix. So if we hop over to the PE device and do a show IP root VRF for customer A, we can now see two prefixes here learned. One via EVGP, which is here on customer A CE1, and one what's perceived to be IBGP, which has been learned from PE2. Now we can see these in the VRF on the PE device, but can we see these on the CE device? The answer to that is no. So we need to add an additional piece of configuration to the PE devices, as we're using the same autonomous system number for both of the CE devices, 1000, 1000 on each end, and 2000, 2000 on the other end. So return address family IPv4 customer A 217.31.1.1 AS override. Customer B 7 with an AS override. And out of that, let's get on this side as well. This allows the PE device to rewrite the AS number. Obviously, as you know, with it being the same AS number on the customer edge devices, it's expecting a full meshed IBGP session. The customer edge devices, obviously, but they have the eBGP pairing to the provider's network. Therefore, we need to get rid of the 1000 in the AS path and rewrite that with well, we're going to rewrite that with 100. Neighbor AS override 5. Yep. So if we come back over to here to CE1, show IP root, we can now see that is in our local routing table of the CE device as an eBGP route. Let's try see if we have reachability to this. 100, 2. Okay, so we do not. Yeah, no, we do. So we need to source it from the loopback. There we go. We're obviously sourcing it from the loopback because we are not advertising the point-to-points into BGP, so the other device over here wouldn't know a route back to it. We'll just look at that to confirm. So yeah, we know the route back to the loopback, but not back to the point-to-points. Okay, and we can have a quick look as well at the AS path on here. So it was learnt by VRF. There we go. So here is the prefix that we're learning from, essentially PE2. Our next hop is PE1, and the path is 100. We'll just check customer B as well. Okay. So now we can go ahead and look to implement traffic engineering for customer A. So let's go back over to customer A and let's do a trace route to this loopback address of CE2 for customer A. So if we follow the path here, so hopped PE1 expected, then here a hop to P1, and then we're going to PE2, and then finally traffic is being delivered to CE2 on the other end of PE2. So we want to change this using IP explicit path to take this bomb here, so shift the traffic for customer A to go this, but only for CE1. So anything that CE1 is sending will go this way, anything that CE2 sends back will go this way. We will have to set up different tunnels if we wanted to perhaps influence the traffic to go this way for CE2. So how we do this is we start off by coming over to PE2, as this is where we want where we want to point the tunnel to. See if we have a loopback already set up, which we do. So loopback 1111. So show run. So you're going to need to set up a dedicated loopback for this. As you can see, I already have loopback 1 set up for this. So this isn't advertised into the IGP, which is OSPF. So what we're going to need to do is, now we've set up this here, we're going to need to come over to PE1. And enable the tunnel. And under here we're going to need to do tunnel mode MPLS traffic engineering, tunnel destination, and this will be the primary MPLS loopback. So loopback 0, for example, of PE2, so that in my case is 10.0.0.5. IP, and we're going to need to create an explicit path as well. So we'll quickly drop out the tunnel, and we will create IP explicit path name PE2 test. So we're now under PE2 test, and we're going to use the next address command to specify the next hop. So I believe we'll just check here. We are 8 and 6, so we want to go 8, 7. So we need to build a path of 874. Over here, so 10.0.1.8 7 4. Okay, interface tunnel 0. We also need to do IP address. IP address. Nope, nope. IP unnumbered. Loopback, and for this loopback 0 as well. And then you need to do tunnel MPLS traffic engineering path option. This is going to be the first path option, and this is going to be an explicit path followed by the name of PE2 test. Okay, at which point we should then see the tunnel come up. Show interface, show MPLS traffic tunnels. So path is valid and we are connected. And this is the path that it's going to take. So if we come back to CE1 and try the trace route again, we can still see that the path remains the same. This is because we need to change the BGP next hop on the VRF at the other end of the tunnel to point to that loopback that we created. And then we need to create a static route on PE1 pointing to that remote loopback and send it over the tunnel. So we're going to come to PE2 and we're going to drop under the VRF. VRF definition customer A address family. I think is it under the address family. BGP next hop, loopback, and loopback 1, which is the dedicated loopback that we created here. So try again. Traffic is still transversing the network, so but obviously not taking the explicit path we want. But let's have a look at some of the changes that have now happened. So let's do a show IP BGP VPN before all. We can see here that the prefix that was advertised via CE2 on customer A's end into PE2, which has then been advertised to PE1, the next hop has now changed to this address here, 1.1.1.1, where before it was the next hop of loopback 0, which is known in the OSPF process, which is the route to take via P1. So as this isn't advertised in any IGP, we need to advertise, we need to create a static route to this IP going over the tunnel. It's very simple to do, so conf t, I want to do IP route 1.1.1.1 2.5 tunnel 0, and that is it. So come back over to custom A and let's try and run the trace route again, and this time that we can see that it takes the explicit path and traffic has now been shifted from G0/0 and now shifted onto G1/0. Traffic coming back to CE1 of customer away from CE2, like we said earlier, will still take the shortest path, as we haven't yet defined an explicit path for traffic coming from the other way. Traffic engineering tunnels are unidirectional, so they need to be set up in both directions. So I hope that gives you some understanding. It's a very high level overview, very simple configuration, very simple setup here. If you would like any tutorial on how to set up an MPLS backbone, so setting up LSRs and LERs, just leave me a comment below and I'll look at doing a video on this very simple setup here. But in the next couple of weeks to come, we'll be looking at quite a larger topology with route reflectors and stuff like that integrated in for the PEs, BGP neighborships. We'll also be looking at VPLS as well, and some. If you would also like sort of layer 2 pseudo wires or anything like that, just leave me a comment below and I can look at doing that. Cheers, thanks for watching.